Okay, page 3 of the trigonometry bookwork. Number 1, in triangle PQR, angle R is 90, angle P is 21, and length PR is 15. Represent this information in a clear and labeled diagram. Write down the size of angle Q and find QR. And here they give you a hint to label the triangle in alphabetical order clockwise. Okay, so the three vertexes here are P, Q, and R. P, Q, and R. And it says R is 90 degrees, so we're going to have to draw the triangle kind of like this. R 90 degrees. Okay, angle P is 21. This is 21 degrees. And PR is 15 centimeters, so that's 15. And then so we labeled it in a diagram, okay? And then we go on to B. B says to write down the size of angle Q. Okay, how do you figure out the size of angle Q when we only know the angle 21 degrees, angle P? Well, remember that we do know that angle R is 90 degrees. So we know two of the three angles. And if we know two of the three angles, then we can use the fact that all three of the angles added together is 180 to figure out what angle Q is. So we have 21 degrees plus 90 degrees plus angle Q. Oops, I'm going to write it in the IV notation, which is to make a Q and then put a little hat on it. And then I'm going to make that add up to 180 degrees. Okay? And then I'm going to put 111 degrees plus Q. I added together 21 and 90. And then I'm just going to use a little bit of algebra. I'm going to subtract 111 from both sides to get the measure of angle Q, which is going to be 69 degrees. Okay? So angle Q is 69 degrees. So that was B. And then it tells us to find QR. Well, QR is this length here. And we can find that using one of the trigonometric relationships. Okay, so like for example, we know this side, 15, and we want to know this side. And we know all the angles, but let's say we know the angle 21. So what's the relationship here? We could say that the tangent of 21 degrees, and the reason why we're using tangent and not sine or cosine is because we don't know the hypotenuse, and we don't want to know the hypotenuse, so we're not going to use sine or cosine because both have hypotenuse. So we're going to use tangent of 21, and the opposite in this case is going to be QR, which we don't know yet, but we want to know, and it's going to be divided by 15. So now we're going to say QR is equal to 15 times the tangent of 21 degrees. And then we're going to go to our calculator and we're going to say, what's the tangent of 21? And I hope I have it in degrees mode. I don't think I do because it gave me a funny answer. Now I'm going to go mode, and then I'm going to go down here to degrees, choose degrees, and go back to the regular screen. I'm going to do tangent of 21 again, but this time it's going to know I'm talking about 21 degrees, and it gives me 0.384, okay? And it's so I'm going to have 0.384 times 15, and then it's going to be 5.76. 5.76. Okay? 5.76. Okay. All right. Now we're going to number 3. In triangle ZWV, that's kind of funny. It says to label to alphabetical order clockwise. They give us ZWV. That's not in alphabetical order. Okay, so ZWV, alphabetical order would be VWZ, right? Okay, so we'll label it VWZ. And V is 90 degrees, so V is going to be this one, and then W and Z, we're going clockwise. Okay. So V is 90 degrees, W is 15, and Z, let's see, WV is 30. WV is 30 long. Represent this information in a clear and labeled diagram. There we go. Write down the size of angle Z, okay, and find VZ. Okay, So again, we find the size of angle Z by adding up all the angles and finding that they add up to 180. Okay, so we're going to have 15 degrees plus 90 degrees equals 180 degrees. And then we're just going to solve for angle Z. Okay, so I won't go all the way to the end, but you know how to do that from the previous problem. Now we need to figure out what is this length. And we don't know that length, but we want to know it. We do know this length is 30. And we do know this angle. It's 15. So let's see. We could write a trigonometric expression relating the purple to the orange side and the orange angle. We could say the tangent, and the reason why we're using tangent again is because we don't know the hypotenuse and we don't care to know the hypotenuse. Tangent of 15 is equal to VZ over 30. And so then we just need to find the tangent of 15 degrees, and then we can put it in there, and then we can solve for VZ. So I'm not going to do that for you here, but you can do that by yourself. Number 5. In rectangle ABCD, DC equals 12 centimeters, and the diagonal BD makes an angle of 30 degrees with DC. How nice, they made a drawing for us. Find the length of BC. So we want to find the length of BC. We don't know it. Okay, so I'm going to put the purple for unknown. Find the perimeter of the rectangle ABCD and find the area of the rectangle ABCD. Okay, so let's see. We want to know BC, and we do know this, and we know the angle. So how can we relate those? Well, obviously it's tangent, because tangent doesn't involve the hypotenuse, and we don't know the hypotenuse, and we don't care to know it. So we're going to put tangent of 30 degrees, and we're going to put the purple, which is BC, over the orange, which is 12. Okay? And then we're going to solve for DC. First of all, what's the tangent of 30? Tangent of 30 degrees is 0.577. So I'm going to have 0.577 equals BC divided by 12. I'm going to multiply both sides by 12. So I'm going to have 0.577 times 12. That gives me 6.93. So BC is equal to 6.93. That's the answer, part A. Then part B says, find the perimeter of the whole rectangle, which would be all the way around the rectangle. And we do know that the orange is 12, and we know that the purple is 6.93. So if we want to find the perimeter, all we need to do is add 12 plus 12, because the other side is also 12, and 6.93 plus 6.93. And now we'll have the perimeter, right? That's B. What about C? It says to find the area of the triangle ABCD. Well, remember, the area is equal to length times width. Length would be 12, width would be 6.93, so we'll just multiply 12 times 6.93, and then we'll get the area. Okay? And I'll just do this for you with offline calculator. Okay, so it would be 24 plus 6.93 plus 6.93, and then we'll get 37.9. And then we'll say 12 times 6.93, and that gives us the area, which is 83.2. Okay, moving on. A ladder 7 meters long leans against a wall touching a window sill and makes an angle of 50 degrees with the ground. Represent this information in a clear and labeled diagram. So we got a ladder that's 7 meters long against the wall touching a window. Makes an angle 50 degrees with the ground. 50 degrees with the ground. Okay. Represent this information. Okay. Find the height of the windowsill above the ground. So what we want to know is this purple line here. How far from the foot of the ladder is the foot of the wall? So that they're talking about this part here. So now we know the hypotenuse. We don't know the opposite or the adjacent. So we can't use tangent. Doesn't do us any good because we don't know opposite or adjacent. But we could use sine or cosine. For example, we could use cosine. If we use cosine of 50, we could figure out, like I'm going to call this one x and I'll call this one y. We can figure out what x is because cosine of 50 degrees is x over 7. So that means x is equal to 7 times the cosine of 50 degrees. Let's figure out what cosine of 50 degrees on the calculator. Cosine 50 equals 0.643. So this is 0.643. I'm going to multiply it times 7, and I'm going to get the final answer for x, which is the distance of the ladder from the foot of the wall, 4.50. 4.50. Okay, now I'm going to find the final answer for y. Y is equal to y over 7 is equal to the sine of 50 degrees. Okay, so y is equal to 7 times the sine of 50 degrees. Okay, the sine of 50 degrees is sine of 50. 0.766. Okay, so 7 times 0.766. So let's see. 5.36. 5.36. Okay, so that's y. Okay, x was 4.5. All right, moving on. This is telling you how to do problems using inverse cosine. So we'll just go to it and start doing problems. Okay, so give your answers correct to 3 significant figures, as usual for IB. Explain the meaning of, so it says, explain the inverse sine of 0.6. Basically what this is saying is the angle with a sine of 0.6. Okay, notice there's a -1 there, so it's not sine of the angle 0.6. It's the opposite. It's what is the angle with a sine of 0.6. Okay, what about this one? This one says the angle with a tangent of 1/2. Okay, and then what about this last one here? The angle with a cosine of 2/3. Okay. Number 2, calculate inverse sine of 0.6. Okay, now they want to calculate it. Okay, so now let's use the calculator. And we'll put 0.6, and then we're going to get the inverse sine of it. Oh, whoops, I'm thinking I'm on a different kind of calculator. On this kind of calculator, you do second sine, and then you do 0.6, and then it comes out right. 36.9. So the degrees is 36.9 degrees. And I don't know how to make a degrees with this computer, so I'll just write degrees. Okay? Then we're going to the next one. So the next one is inverse tangent of 1/2, and we're going to calculate it. So we're going to say inverse tangent, second tangent of 1/2. I could write 0.5. It's easier to write 0.5 on the calculator. 26.6 degrees. Okay, so 26.6 degrees. I bet you appreciate the fact that I'm writing it with the typewriter, with the typing, with the keys, and then you can read my writing easier. Inverse cosine of 2/3. So we'll go inverse cosine of 2/3. Okay, 2/3 is easier to write with a fraction. 48.2. 48.2 degrees. Okay, moving on. Find the acute angle alpha if the sine of alpha is 0.2. Let's see. Basically what they're asking is, and I'm going to have to use a pen for this, unfortunately, sine of alpha equals 0.2. We don't know what alpha is, so we need to take the inverse sine of both sides. If we take the inverse sine of sine, we get just the function. We get the variable. If we take the inverse sine of the right side, we'll have inverse sine of 0.2. And we can do that with the calculator. So we'll do inverse sine of 0.2. 11.5. Okay. Going to C. We have tangent of alpha equals 1. We don't know what alpha is. So we need to isolate the variable like we usually do in algebra. We're going to take the inverse tangent of both sides. So the left side is going to be alpha, and the right side is going to be inverse tangent of 1. Let's see, what is the inverse tangent of 1? Inverse tangent of 1. It's 45 degrees. Okay? All right, moving on. And they asked for an acute angle. Why did they ask for an acute angle? Because actually there's more than one angle that has a sine of 0.2. And we'll talk about more about that later, but for now, pretty much what the calculator gives you is the smallest angle possible. Okay? Find the size of two acute angles in these triangles. Okay, remember acute angles are angles that are less than 90 degrees. So obviously they're not talking about the 90-degree angle. Okay, so in this case here, we have 9.5 and 7. And we're going to find out what this angle is and what this angle is. We can do that because we have a relationship which relates those two legs and one of these angles. Let's start with angle A. Okay? So angle A, we have a trigonometric relationship which relates 7 and 9.5. It's called tangent. The tangent of A is equal to 9.5 divided by 7. Okay? 9.5 divided by 7. Let's calculate that on my offline calculator, which is much faster. 1.36. Okay? Now, how do I find out what the angle A is? I just take the inverse tangent of both sides. If I do, then I get angle A equals the inverse tangent of 1.36. Now I'm going to have to use my TI-84. Inverse tangent of 1.36. The answer is 53.7 degrees. Okay. Now, how do I find angle C? Well, I could use tangent again, but instead of using tangent, I could just say, hey, C is equal to 180 minus 90 minus angle A, which is 53.7. To make a long story short, it's actually 90 minus 53.7, which is 36.3 degrees. Okay? All right, moving on to C. We know this and we know this, and we want to know the two acute angles. Okay? Well, let's say that we want to know the angle Q first. Okay? If we want to know angle Q, what trigonometric relationship relates the 10 with the 12.5? Well, actually, it's the sine of angle Q. The sine of angle Q is 10 kilometers divided by 12.5. It's the opposite over the hypotenuse. Let's see what that is on the offline calculator. It's 0.8. Okay? So now we can use the inverse sine and figure out that the left side is angle Q and the right side is the inverse sine of 0.8. What is the inverse sine of 0.8? Inverse sine 0.8. And we get 53.1. 53.1 degrees. Okay? Now the last one. I'm just going to set it up for you because, oh, by the way, we forgot to get the angle M. But remember, angle M you just find by taking 180 minus 90 minus 53.1. So that's basically 90 minus 53.1. You can figure that out. Last one. We'll just set this up. So look, you got this angle, or you got this side, and you got this side. We want to figure out the angles. Well, since we don't know the hypotenuse and we don't care about the hypotenuse, let's just take this angle, angle I, and then we'll say that the tangent of angle I is equal to 2.6 divided by 7.2. Okay? 2.6 divided by 7.2 on the offline calculator gives us 0.361. 0.361. Okay, now we're going to take the inverse tangent of both sides. The left side becomes angle I, and the right side becomes, let's see, what is the inverse tangent of 0.361? And we get 19.8. 19.8 degrees. Okay? And then how do we get angle K? Or angle J, actually. Angle K, of course, is 90 degrees. Angle J is just going to be 90 degrees minus 19.8. Okay? And that's it.